Hello and welcome back. Today I have a board with a stepper motor and a joystick connected. I wanted to use the joystick to control the speed and the direction of the motor. We'll walk through the components connected and then jump into the code and see how it was done. This is the ESP32 rover board. You don't need to use this board. You could have used any one of the multiple versions of Arduino boards that are out there, Uno, the R3, whichever. You might have to change the pins that are connected to it. We'll get to that in the code, but it would work pretty much the same with pretty much the same code. Here's the joystick. Don't worry about those jumpers. I'm just using them to keep the board still on the breadboard. They're not connected to anything. Those on that side too. So we have the joystick connected to various pins, as well as the stepper motor driver board. The driver board is also connected to the stepper motor via its connector that comes with the kit. For an example, here is one of the joysticks. These are a 3-axis. These have 2 potentiometers, one for X and one for Y. Hopefully you can see it. There's a little button there, but if you press straight down you can hear it click. That's for the Z axis. I'm not using any of those at the moment. I'm just using this direction. The X, you'll see in the code what I've done with it. Always remember that never connect your stepper motor and driver board directly to the 5 volts of whichever board you are using. It is much better to use the power supply. You'll see that there I've connected the plus 5 and ground volts to the existing power supply that's underneath this ESP32 board. I do have another power supply for an example. As you can see here, they come in various shapes and forms. This one you can connect anything from 7 to 12 volts to, and it has an on-off button. It's not connected at the moment. This would do the same as this power supply here. The reason why you don't connect it directly to your board is because the stepper motor can draw up to 230 milliamps, which in most cases is too much for these little microcontroller boards. If it doesn't damage your board the first time, there's a good chance that in the long run it's going to do some damage to your board, make it completely unusable, or burn a component. So always remember, stepper motor drivers or motor drivers, please connect them to your power supplies. So let's move the x-axis and see what happens to the motor. So you can see when I push it forward, the motor turns clockwise, and backwards the motor turns anti-clockwise. I can change the speed by slightly pushing down on the joystick, and you'll see there the lights on the motor driver will also change as the signals are processed. So the more forward that I push, the faster it will go. It will do the same in reverse. And I can go forward and backwards as many times as I like. This specific motor has a gear reduction system inside it. So the speed that it rotates at is not as fast as some other stepper motors that you might find out there. Obviously the larger ones can turn much faster than this one can. What you lose in speed here, you gain a little bit in torque. That's why a lot of people use these motors for raising and lowering blinds and things that require a little bit more torque. Let's jump to the code so that I can explain a little bit on how this works. I managed to do this in 38 lines of code. I did import the library included with the install of the IDE, Stepper.h. This will help you a lot in configuring your motor and getting it running with the least amount of code. You can open up Stepper.h and have a look basically it's just a table on how the signals are controlled for the various types of motors. 2, 4, or 5 wire motors. And if you scroll down a little bit, you'll see how they've programmed them. You don't need to do anything with Stepper.h. This is a standard library shipped with the IDE, and it should have been installed when you installed the Arduino package. In this section here, I've defined the pins. Here is the joystick. I've used an array, but I'm only using pin X. Pin Y and Z are defined, but in my code I'm not using them at all. I'm just using the forward and backwards, positive and the negative motion on the X-axis. Here we initialize the stepper using the pins that we defined before. In the void setup, I've initialized the Serial plugin so that you can see the X moving here at the bottom. We'll get down to that in a moment. And in the main loop, all I do is that I do an analog read on the pin that's connected to the X value of the stepper motor through the motor driver board. They are marked. On your board you should have some label that says VRX, VRY, the ground pin 5 volts, and the switch. The switch is the Z. Here I'm just doing a print of the value from the analog read on the X pin, which you can see scrolling at the bottom on the serial monitor. That will change when we move the joystick, so let me move it quickly now. If you follow it along, hopefully you can see it's scrolling rather fast. Currently it's at 2,800 and some change. And if I push it forward, the maximum is 4,095. Pulling it backwards, you can see it goes down to 0. And then some values in between will change the speed of the motor. To be able to change the speed of the motor, what I did was I used the map function. What the map function does is it takes a range of your two numbers. I'm defining the X value here in the positive direction from 3000 to 4095, and I've mapped it to the speed of the motor between 1 and 20. Those values there will depend on the motor that you have. With the gear reduction that I have installed in the motor, you cannot go more than 15 to 20. Some of the other larger stepper motors you can go into the hundreds and you can race along with your motor. In the opposite direction, I had to change the mapping to face the way that the joystick is pulled. So in this line it's a positive and that's negative if you're looking at the x-axis. By reversing these two numbers here, instead of it being sequential like those, in reverse I was able to map it to the 1 to 20 for the speed of the motor, because the motor turns in the opposite direction. And then all I have is 3 if statements on what the motor needs to do in between the various ranges. Here I'm using the X value. And if it's above a certain range, all I'm doing is setting the speed in the clockwise direction, myStepper.setSpeed, and I'm stepping 1 step forward each time the loop is completed. The exact same for the opposite direction, and here I'm just in between a range for what to do when the joystick is in its center position. These lines of code here just make the pin low that's connected to the stepper motor driver board so that you're not using any power while the joystick is in its center position. I had to put a small delay in. The reason for this is when the joystick changes from its X positive to X negative, the motor doesn't hang because it's confused. If I go too fast, there you can see it's not jammed, it just doesn't know what to do because it received too many signals at once. So now if I do move it backwards and forwards and allow for that little time delay to come through, you'll see that the motor can go backwards and forwards any way that you like. I'm hoping that this code will fit in the comment section below the YouTube video. If it does, I'll gladly paste it there. Let me know in the comments if you have any questions. Thanks for watching.